Thinking to yourself, oh, I'm so bummed because this isn't a PowerPoint presentation. And let me encourage you by saying that at some point during this video, I will sing to you, I promise. Today we're talking about the quadratic formula. We've only got 3 questions to answer about the quadratic formula. The first is, what is it? The second one is, why bother? And the third one is, how does it work? Shouldn't take too long, so let's dive right into it. The quadratic formula is, well, it's a formula that gives us a solution to any quadratic equation. The formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is a big mess of letters with only a couple numbers in there. Don't let it intimidate you. Remember, a, b, and c are all part of our definition for a quadratic equation. That is ax squared plus bx plus c equals 0. And anytime you have an equation that has these 3 parts in it, you can solve it using the quadratic formula as long as you remember it. Remembering the quadratic formula is the hardest part about using the quadratic formula. To that effect, I have prepared a song to help you remember. It goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have it. To the tune of Pop Goes the Weasel. If you say that to yourself 7 times in a row, sing it, I should say, to yourself 7 times in a row while you write it down, you'll never forget it again. I do recommend while we're doing this assignment, every time that I write it down, or then later when you're doing your practice that you write it down, that you say it to yourself while you write it, while you listen to yourself. Singing can only help. Because the more ways that something interacts with your brain, the more likely you are to remember it. So speaking it and hearing it and seeing it and saying it all at the same time means you're much more likely to remember it. That being said, let's move on to why bother. The quadratic formula is actually the result of what happens when you take this equation with no numbers and only letters and complete the square. If you complete the square on this and solve for x, you'll get this formula. And what that means is the square is already completed for us. We don't have to complete the square if we know the quadratic formula, or I should say, if we know the quadratic formula, the square is already completed. We just have to put the numbers into their correct spots. The reason this is nice is that not everything can factor. Really, factoring is flat out easier and better than using the quadratic formula, but it doesn't always work. In an example like this, x squared plus 10x plus 16 equals 0, factoring will work. 16 has several factors, but the ones that add to 10 are 2 and 8. So I can factor this to x plus 2 and x plus 8 right away without too much thought, which tells me my solutions are x is negative 2 or x is negative 8. And that's way better than using this quadratic formula. But if I change the equation just a little, 10x plus 17 equals 0. Now the only factors of 17 are 1 and 17, and they certainly don't add to 10. I am never going to be able to factor this. So the quadratic formula is how I get out of having to complete the square myself. It's already completed. I just have to put stuff in the right spot. Now remember, if we're using ax squared plus bx plus c as our format, a is the number in front of x squared, which in this case is a 1. B is the number in front of the x, which is a 10, and c is the number by itself, which is 17. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a means that x is the opposite of b, 10 is b, so the opposite of b is negative 10, plus or minus the square root, b squared will be 100, minus 4 times a is 1, and c is 17, all over 2, again a is 1. Now all I have left to do is arithmetic. Arithmetic isn't so bad. Some of this is a little complicated. So like I said, if you could factor it, do that. But that ship has sailed. Now 4 times 1 times 17 is going to be 40, and 28 is 68. So 100 minus 68 in the square root. 100 minus 68 is 32. So 32, if I need to simplify the square root, 32 is 16 times 2. Notice 16 is a perfect square. So that's, the square root of 16 is 4, leaving a 2 on the inside. Now I divide them each by 2, so 10 divided by 2 is 5, and 4 divided by 2 is 2. And this is my solution, -5 plus or minus the 2 square roots of 2. I should say my solutions, that's 2 solution, -5 plus 2 square roots of 2, and -5 minus 2 square roots of 2. Since this is radical, it's irrational, I would never have been able to factor because the factors are not, well, they're not rational numbers. There's no way that would have occurred to me as a factor. So the real point for the quadratic formula is there's problems we can't factor. The quadratic formula always, always, always works to solve quadratics. In fact, it works so well that it will work on the nice ones too. It's just, that's a whole lot of math you didn't really need to do. In this case, opposite of b would be -10 plus or minus the square root. B squared is 100 minus 4 times 1 times this times 16 instead of 17, although a is still the same. So that's -10 plus or minus the square root of 100. 4 times 16 is 64. Notice 100 minus 64 is 36. So that gives me the square root of 36, which is 6. -10 plus or minus 6 over 2. -10 plus 6 is -4, which makes -2. And -10 minus 6 is -16, which makes -8. The same solutions we found by factoring. So the quadratic formula will always work. And I say as a general rule of thumb, if you spent longer than a minute or two trying to factor, you're wasting your time anymore, and you should just go to the quadratic formula. Let me do another example that you would not be able to factor yourself. For this example, we're going to use 2x squared plus 6x plus 15 equals 0. Now you could start looking for factors, so you could do 2 times 15 is 30. We need numbers that multiply to 30, that add to 6. It's never going to happen. So the opposite of b, in this case -6, plus or minus the square root, 36, 6 squared is 36, minus 4 times a is 2, c is 15, all over 2a is 2 again. So there's the quadratic formula. Notice the inside here becomes 36 minus 4 times 2 times 15 is going to be 120, which is a problem because that's going to be negative. In fact, -84. Now immediately I notice this is not going to be a real number. It's plus or minus, so it's going to be 2 imaginary numbers as my solution, which is something you should completely notice. This part underneath the square root, in fact, b squared minus 4ac, has a name. It's called the discriminant, because we can use it to discriminate between problems that will have real solutions and problems that won't. If b squared minus 4ac is greater than 0, you're going to have 2 real solutions. If b squared minus 4ac is less than 0, you're going to have 2 imaginary solutions. Now if b squared minus 4ac works out to be exactly 0, you're going to be adding or subtracting 0, and you're going to have 1 real solution. Or if you like, the same solution twice, because adding 0 and subtracting 0 are the same thing. In any case, for this problem, to simplify this, notice the -1 becomes I. 84 is 4 times 21. The square root of 4 is 2, and the square root of 21 does not simplify. So this is -6 plus or minus 2i times the square root of 21 over 4, also known as -3 plus or minus I square roots of 21 over 2. 2 imaginary solutions. This is how you use the quadratic formula. I'm looking forward to see you doing it in class.